Hello, Miska.
Hello.
Okay, so are you ready now?
Yeah.
So let's start with our session. So today we will discuss about eclipses. So are you familiar with this already?
I just know that it just blocks the sun.
Yes, it blocks the sun, and there are two types of eclipses. So we will discover that one today. So before that, these are the things that you will learn for this session. First is to learn about why we observe solar and lunar eclipses. And the second is to discover what we can learn from eclipses. And last one is to find out all about the different eclipse events. So let's start now. First, look of this video first. So
Okay.
try to determine if what type of eclipse this one, or just guess if what type of eclipse this one first. Okay, so based from that video, do you have any idea?
It was like really quick.
Yes, so is it for that video, is it lunar or solar?
I don't know the difference between both of them, but I think lunar.
It's lunar. Okay, so let's try to check if it's really lunar eclipse.
I'm not sure, so it's a guess.
Okay, give me a moment first. So that is a solar
Oh,
eclipse. So in that video, if you can see, it's daytime. So usually when we talk about solar eclipse, from the word solar, it comes from the sun. So blocking of the sun's shadow. So what is a solar eclipse? So solar eclipse is a stunning astronomical event that occurs when the moon passes between the earth and the sun, casting a shadow over earth. So if you try to look this picture, so it is from the sun's light. So it is being covered by the moon. So it is the position of this, it will be the sun, moon, and earth. So though the sun is bigger than the moon, but still it will be covered because of the distance. So still, if this alignment happens, so that's why a solar eclipse occur. So let's find out what causes a solar eclipse. So basically, solar eclipse exists because of this cosmic alignment behind the event. So this happens when the moon moves directly between Earth and the sun. So the moon will be at the center of this. So this one is when it blocks the sunlight and casting a shadow on Earth's surface in specific locations. So this alignment only occurs during a new moon phase. So last time we discussed about new moon or the phases of the moon. So this time it happens during a new moon phase. And also the tilt of the moon's orbit makes solar eclipses relatively rare events compared to lunar eclipses. So if we heard it from the news, mostly we always heard about the news of having a lunar eclipse every year. So there are several lunar eclipses that will happen every year. But in solar eclipse is just a rare event that it will happen. So it's not it happens every year, but it can be once only. But when we talk about lunar eclipse, it can happen like for several times in a year. So let's find out what are the types of solar eclipse. So basically, we will have four types of eclipses. We have the total solar eclipse, and then the partial solar eclipse, and we also have annular solar eclipse and hybrid solar eclipse. Let's find out what are these types. So let's start with the total solar eclipse. Can you read this one first?
A total solar eclipse is the most dramatic type, plunging areas into darkness for a few minutes during daylight. The sun's coronal becomes visible, glowing around the moon's edge. This inspiring event has intrigued humanity for centuries, often offering both scientific insight and a breathtaking natural display.
Okay, so this one, if we talk about the total solar eclipse, so this is where all the areas is will have when you say total, so it's fully covered. So it's really during daytime. Solar eclipse happens during daytime, and if this happened, usually it turns out that the surroundings will become dark. So it's like a nighttime, but it's because the sun is being covered. But at this moment, it happens for about a second only. So sometimes people will not recognize that there is a solar eclipse that happens because of its very short period of time that will occur. So it's just you will heard it from the news, but commonly people will not usually know that there is a total solar eclipse that happens because it will only last for seconds or just a minute. So it will not take a long time. So let's go to annular and partial eclipses. So basically, these two types of eclipses. Can you read first the first one, the annular eclipse?
The moon is too far from the Earth to completely cover the sun, resulting in a bright outer ring, an unforgettable and striking solar halo effect.
Okay, so in this part, since the moon is very far from the Earth, so you can just also see the shadow away from it. So it's like there is a bright outer ring. So if you can see this picture, you can still see that there is a circular size around it because it is not fully covered by the moon.
Ooh.
So basically, if we talk also about partial eclipse, this is the only part of the sun is blocked by the moon, making the event less dramatic but still fascinating to observe with proper protective eyewear. So when we say partial, it's from the word partial, it's only half of it that is being covered. So if we compared it to this annular eclipse, so it will be like fully covered. So it's like the moon passes in front of the sun, but it appears slightly smaller. So though it is covered in annular, but it's not really fully covered it since it's just this the moon is just small that cover the sun. But you can still see that a bright ring of fire remains around the moon. So this annular, there is still a ring on it that you can see. So it's like a shining ring around the moon. And when we talk about the partial solar eclipse, it is when the moon covers only part of the sun. So only part of the sun that is being covered here. So that's why it's like a part or a partial of it. So here, the sun looks like it has a bite taken out of it. So it's like if you eat a donut, so it's like a small part that is being eaten. So it's like you can see that there is only a part of it that is showing. So this one, commonly partial solar eclipse is more widely visible than a total eclipse. So mostly in our countries or other places around the world, this partial solar eclipse can be always, we can always see this one because it's just partial. So it also matters if where are you in the specific part of the earth. So if you are near, like there are just certain countries that they can see the full solar eclipse. But basically or commonly, we will usually see only the partial eclipse. So now let's talk about the path of totality. So here, these are the width and the variability. So we have the totally path is typically 100 to 200 kilometers wide and varies with each eclipse due to its rotation and the moon's distance. So that's why there are different types of solar eclipse because it still matters how the earth's rotate and also the moon, the distance of the moon from the sun and to the earth. So when we talk about totality, it's like total. So it's like this narrow band is where a total eclipse is fully visible. So viewers outside, it will only see a partial eclipse. So if you are in that certain location, you can see that the whole solar eclipse, but commonly we will just half of it. You can only see partial eclipse. So importance of planning. So to experience a total eclipse, one must be within this path. Prompt planning ensures ideal viewing locations and conditions. So let's go also about the frequency and rarity of this. How often does it happen? So since some of people are excited about discovering or witnessing this kind of phenomenon. So that's why how or let's discover how often does it happen. So solar eclipses at least twice a year somewhere on Earth. So but total eclipses in any one location are much rarer and can take decades to reoccur. So imagine it's like decades that you will wait for you to witness a total eclipse because commonly we will just only see about like partial eclipse. So because of this orbital dynamics, many factors must align for a total eclipse to occur. So making each one a special opportunity for scientific study and public engagement. So it's very also important to study solar eclipse because it will also provide different like studies from scientists. So we will discover later on why do we really need to study about solar eclipse or what is important of this phenomenon. So just a reminder, if you try to look about or if you try to witness this phenomenon, you should always remember the safety tips for viewing because you should not use your eyes to see, to view the solar eclipse directly because it will really damage your eyes. So that's why there are certain like recommended glasses that you should wear when you want to view this phenomenon. So first is only wear ISO certified solar viewing glasses to prevent permanent eye damage. So ordinary sunglasses are not safe for direct solar viewing. Why is it that we need to use this recommended eyeglasses? Because during this time of event, our sun emits a strong radiation, and this radiation can really damage your eyesight. So if people will view this one directly, probably they will experience some of blindness, like it can be permanent blindness if you will directly view this one without using any glasses. So also, we can try projection methods. So pinhole projectors or eclipse viewers provide a safe way to indirectly observe the sun without direct exposure. So there are also you need to follow regional advice like pay attention to local announcement regarding eclipse visibility, also weather conditions and safety tips to get the most out of your experience. So just remember that don't you ever like try to view solar eclipse using only your naked eye because it will really damage your eyesight. It cannot be you will not experience a sudden blindness, but it will slowly damage your cornea or part of your eye. So these are the reasons why scientists observe solar eclipses. So scientists study the corona, which is a part of the sun's atmosphere, during the total solar eclipses to learn how the sun's heat and energy move into space and what it does to our earth. So it's not just that solar eclipse will just exist, but there is also a benefits of it. So that's why scientists need to study this phenomenon. So the total solar eclipses are especially important because they allow scientists to see the corona that's too faint to see exact when the bright light of the sun is blocked. Again, they need to study this one because it is important for them to identify the sun's heat and energy. So, if how strong the heat that will be entering our earth, and also it will also provide ideas for us if that kind of energy from the sun is still safe. So, to recall about what we discussed about the sun. So, again, the sun is a big star that gives us light and heat. So, it also sends out something called the solar wind. So, solar wind, which can affect our technology. So, this is also important so that we will identify, especially nowadays we use technology. So if there is a solar wind, sometimes it will affect our how the connection with our mobile devices. And also just to also that scientists or people will go to outer space, it will also important that they will know this kind of event. So scientists want to know how the solar wind starts so they can be ready for any problems it might cause. Not only it the if or the effects of it or impact of it that will happen on Earth, but also in on how it affects the people who will also study outside the Earth. So during a solar eclipse, scientists can study the Earth's atmosphere in a special way. So that's why it's very important for them also that there is a solar eclipse that will occur. So scientists use instruments called coronagraphs to block the sun's light in a manner similar to a total eclipse. But these instruments still struggle to reveal the region of the corona closest to the sun. So there are still many things that they need to study, but due to this, like a limited of the uses of this instrument, so it's still hard for them to study this phenomenon. And studying the solar eclipse helps scientists learn about the ionosphere. So just to recall, ionosphere is part of the atmosphere of the Earth, and it is where it's a layer of the part of the layers of the atmosphere wherein it blocks the strong radiation coming from the sun. So this is a layer of charged particles created by the sun's energy. So changes in the ionosphere can have significant impacts on technology and also the communication systems and is important for many things like satellites and also GPS. So those are the things that's why we need to study or the scientists need to study solar eclipse. Okay, so before we will proceed to the next eclipse, do you have any questions about solar eclipse?
No, not really, not so far.
Okay, so if you don't have any questions, so now let's go to lunar eclipse. Okay, so let's take a look of this a quick video about lunar eclipse.
Okay.
Okay, so that is how, just a quick video about how lunar eclipse will happen. So, based from that video, so what did you observe from that video?
It was like red.
Yes, so it will turn red from just a normal, and then it will be covered and it turns into color red. So let's discover how these things happen. So basically, when we talk about lunar eclipse, this is it occurs when Earth is between the sun and the moon. So a while ago, when we talk about solar eclipse, it is the moon is at the center. But this time, it is the Earth is at the center between the sun and the moon. So causing Earth to cast a shadow on the moon. So this will be the position of it from sun, Earth, and a moon. So the moonlight we see on Earth is the sunlight reflected off the moon's grayish white surface. So the amount of moon we see changes over the month, and it's called lunar phases, or what we call the phases of the moon. So because the moon orbits Earth and Earth orbits the sun, everything is moving. That's why it keeps changing. So during a lunar eclipse, Earth comes between the sun and the moon, blocking the sunlight falling on the moon. So Earth's shadow here covers all or part of the lunar eclipse. So let's discover now what are the types of lunar eclipse. So just addition, during a lunar eclipse, the moon turns red because the only sunlight reaching the moon passes through Earth's atmosphere. The more dust or clouds in Earth's atmosphere during the eclipse, the redder the moon will appear. So imagine if there are plenty of dust in our atmosphere or plenty of clouds. So that's the time that our moon will also become redder. So these are the types of lunar eclipse. So we have the total lunar eclipse. So if you try to look to the total lunar eclipse, the entire moon moves into Earth's darkest shadow. So this one is our sun. So this is how it looks like. This is our moon. So entire moon passes through full shadow. That's why that's the time that we can see a bright color, this one, a reddish or a red color of the moon. That's like a big one. Next is the partial lunar eclipse. This time, the partial lunar eclipse, it is the only part of the moon that enters the umbra. Umbra is a kind of shadow, and this one is you'll see a dark bite slowly move across the moon. So this one, if you can see this one, this is a partial lunar eclipse, and this is how it looks like when you view this one on Earth. So only part of the moon passes through full shadow. And last one is the penumbral lunar eclipse. For penumbral lunar eclipse, this one is the moon passes through Earth's lighter outer shadow. So the moon here only looks like slightly dimmer, and it's just it's just a sudden also movement of the Earth. So that's why you can witness this one also for a few minutes, or yeah, it can last a minute also. So It's like it will just, the moon that you will see here that slightly dim is like just happen for a short period of time. And this is how it looks like. So it turns out that the moon will go back to its original color and form and also size and how you view it on Earth. So because if you try to look to the total lunar eclipse, this is how it looks like. And then it goes to partial lunar eclipse, this one only half, until it will become a penumbral lunar eclipse back to its original one. So why NASA observes lunar eclipses? So why is it they need to study this phenomenon? So hundreds of years ago, when people observed the moon during an eclipse, they saw Earth's shadow on the moon and discovered that the Earth is round. So even after all these years, scientists are still learning about the moon from lunar eclipses.
Oh, okay.
So here, last December, yes, Miska?
Oh, I was just saying, yeah. Oh, like, oh, okay.
Okay, no question?
No, not yet.
Okay, so let's continue. So just a few information. In December 2011, NASA's Lunar Reconnaissance Orbiter gathered data about how quickly the moon's day side. This is the side that always faces the Earth and cools during a lunar eclipse. So NASA can learn what the moon's surface is made of from this data. If an area of the moon's surface is flat, it will cool or it will cool quickly. And scientists use this data to know which areas of the moon are rough with boulders and which are flat. So these are the things that we need to remember when you are predicting eclipses. Can you read the first one, please?
To understand how Earth and the Moon move around the Sun, scientists need to figure out how their shapes and movements affect each other. They use a gravity to help them understand and how everything fits together.
Okay, so it's basically that they need to study this one. Why do they need to predict eclipses? Is that of course the first one is how the movement of the celestial bodies, the movement of the earth, sun, and moon, because it can also affect how they view or how we view and also how this kind of phenomena affect each other. Next one is using math. They figure out how things move in space. So they also consider how big the celestial bodies are and how they're not perfect circles. So if we talk about sun or moon, it is always in circular shape. So here it is also important to remember that since if it's like around, It's not always that it will be appeared as like that. It's because it still matters if how the movement of it to the sun, and also how this one like differ because of the reflection of the shadow. So the third one is the scientists then feed the current positions and speeds of Earth and the moon into these complex equations. So still, this is also important because this scientists will can identify if how strong or there is a changes or speed of the Earth's rotation, as well as rev- it's like revolve how it revolves around the sun. So basically, they program a computer to figure out where the moon and sun are in the sky. So when we look up from the earth, they can do this by making the computer think about time and how things move backward or forward. This helps them figure out where the moon and the sun are in the sky compared to each other. And last one is eclipses are specific arrangements of the sun, moon, and earth that can be identified by the computer. And they're really good at predicting them. So they can even tell you exactly when an eclipse will start and also end, and even it's hundreds of years from now. So it's like they can determine because of this phenomenon. So it's like we can it can help to identify if how this one will stop showing. Okay, so before we will continue, can you answer this one first?
Um,
This one, you look at the picture and choose if solar eclipse or lunar eclipse.
for the first one, I think it's solar eclipse because the top diagram it's like giving a solar eclipse because the moon and the sun is positioned. Wait, sorry. The moon and the sun and the earth is making a shadow on the earth. So the solar eclipse occurs when the moon blocks the sunlight from reaching the earth.
Mm-hmm.
And
Okay.
then the other one is lunar eclipse because it happens because the earth is positioned between the sun and the moon, making a shadow on the moon, and the lunar eclipse happens when the earth blocks the sun's light from reaching the moon.
Okay, so correct. The first one is solar eclipse, and the second one is the lunar eclipse. Okay, so let's continue. Just give me a second first. So, what can we learn from eclipses? Before that, it's time to spill the cosmic beans. So, can you share what you have learned from that discussion about solar and lunar eclipse?
I
And
learned
what
the
have you
difference.
discovered?
Sorry, I learned the difference between a solar eclipse and a lunar eclipse.
What's what are those differences?
Um, I think the difference between a lunar eclipse and a solar eclipse is like, uh, wait, the word is not coming to me.
Okay, just I give you um a minute to think about it.
Oh wait, yeah. So a solar, I think what I remember is that a solar eclipse happens when a moon passes between the sun and the earth, making a shadow on the earth during the day. But the lunar eclipse happens when the earth passes between the sun and the moon, casting its shadow on the moon at night.
Okay, how about the types of these eclipses? Or is there any types of this eclipse that makes you it's like more interesting to view? Have you tried witnessing this kind of events?
No, not yet. We don't have the glasses.
Yeah, but how about you can use the DIY way? Like I'm gonna show you the DIY's sun, I mean eye protector. Though for lunar eclipse, usually if you will look or view the lunar eclipse, you don't need to. Some people don't need to, or we cannot. It's not. It's real. It's safe, but not super safe that we directly view the lunar eclipse. But compared to solar eclipse, you should never ever try to view it with your naked eye because it will really damage your eyesight. But for lunar, we usually witness that one even without using any protected eyeglasses. So still fine, though is still a little radiation that it will emit, but still not so dangerous compared to solar eclipse. So I'm gonna show you just this one is wait, it's not yet. It's like a DIY. Give me a minute first.
Okay.
So this is the DIY solar eclipse projector. So supposedly we will make this one, but still, since we don't have the materials, this is an interesting projector if you will make a solar eclipse projector. So this one, it's we all know that solar eclipse is like very we need it's very important to protect our eyes. So that's why astronomers have many or have used different methods to observe the sun safely. Because if it involves sunlight, of course, we will be needing uh like more study about this one because it involves a strong radiation. It emits a strong radiation during this time. So what you're going to need here is that, of course, you need these materials. We have empty cardboard, white paper, scissors, aluminum foil, a pin, or and a tape. But you don't have the materials this one at home, right?
Now, fortunately, not.
Because it's really interesting to make this one. Maybe we can make this thing next time if you have materials. So this is in this image, one side of the projector is open to show you how it works inside. So here is where you will view the sun. Then we have the viewing hole, sun hole, and what white paper as acts as a screen. So here it's just you're using the normal white paper.
Ooh, okay.
Now let's continue. So another ways to protect your eyes during a solar eclipse. Yes, we have wear eclipse glasses. So eclipse glasses can be worn to view an eclipse. So you can purchase this one or you can also make your own, but they never recommend anyone to make a DIY glasses because sometimes you will, if you will make a DIY eyeglasses, it also like it's not really safe to use it because of its fake filters. So when when I was still a student like you, we usually make a DIY um protection from the sun from the eclipse. So yeah, it can be also effective because if you will try to look to the sun, it will not really affect. It's not really that bright, but still, even how much you cover your eyes while looking at it to that eclipse, still it will still emit radiation. So it will also you will still also be like hit by the radiation. So we also have used a pinhole projectors. This is what I let you watch a while ago, how to make that kind of projector. So a pinhole projector can be used to view an eclipse indirectly. So they are a great DIY option for those who aren't able to find eclipse glasses in time for an eclipse. So these are the learnings from eclipses according to NASA. Can you read the first one and also the second one, please?
Scientists like to watch solar eclipses because they can learn new things about the air that surrounds our planet, which is called the atmosphere. During the solar eclipse, the air gets a little bit different than normal, so it's exciting to study it. Eclipses have helped scientists learn more about how things work in space. They even prove Einstein's theory of relativity, an idea about how things move in space. They also use eclipse to make a map of the sun and how it connects to other things in space.
Okay, so truly that eclipses are very useful for all of us. It's just not, it will be appear just for a design on Earth that you can see that beautiful phenomenon, but still it will have always an impact and benefits to everyone why this kind of thing happened. So eclipses are a special type of transit where one astronomical object blocks another. So NASA uses transits to study the exoplanets, planets outside the solar system, going around faraway stars. And eclipses can help us better understand Earth's ionosphere. So we had this one also already. So just another information, since we are talking about ionosphere, let's also try to learn what is it because it's part of how we study the system. I mean the different eclipses. So again, we discussed this last time, right? Can you still remember the different layers of the atmosphere? I mean, yes.
The atmosphere, oh yeah, I learned it, but
Which
I don't know all of the names very well, but I do know that. And do know the atmosphere, sorry.
okay, so here if you try to look to this image, this is where ionosphere is located. And the ionosphere is where Earth's atmosphere meets the space. So it forms the boundary between Earth's lower atmosphere here, where we live and breathe. So commonly we have in this part, we got, or it's our atmosphere. Here, the sun acts like a giant stove that heats up gases until they lose some of their tiny particles. So this makes a big pool of charged particles that move around a lot and causes constant changes. So the ionosphere gets bigger and smaller depending on how much energy it gets from the sun. Because of this, the ionosphere changes from Earth's day side to right side. The ionosphere plays an important role in the study of eclipses. So if you can see, it is still from mesosphere going to exosphere. So when and where to see future solar eclipses? So we have here the data last time that this phenomenon occurs. So we have first the solar eclipse. So this one happened in 2023 and 2024. So see how they differ from each other. It's not the same from them. And there are certain places on earth that is where you can witness this kind of eclipses. So this is for 2024, last year. Then
It
for
happened on my
2025
birthday.
and 2026, this one. So these are the things that might happen this year. So if you
Ooh.
try to look, we have March 29, 2025. That was last year. And September 21, also last year. So this time it will be this next month. This month, it's already second month. So it will be February 17, 2026. So this year on this month. So we will witnessing a annular solar eclipse. But commonly this is visible in the Antarctica area. So yeah, not all, though there are many eclipses that will happen every year, but not everyone has the opportunity to witness this event. And also, we have August 12, 2026. This is total solar eclipse. And this is what people usually like about in all types of solar eclipse. So this is visible in South America and total eclipse visible in Arctic, Greenland, Iceland, and Spain. Now let's continue. So these are also the things that will happen in 2027 and 2028. So we have here for February 6 annular solar eclipse. Annular eclipse visible is in Chile, Argentina, and Atlantic. And then we have August 2, total solar eclipse. Then we have annular solar eclipse and total solar eclipse. And for 2029, still this one, everything this one are solar eclipse. We have this partial, 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 and partial. So commonly or basically, usually people will view this one, this type of eclipse.
Ooh. Are those accurate?
Not exactly accurate, but yeah, it's nearly accurate. Like as we can people studying this one can detect the different eclipses. So it's just that they will use the different like instruments how to detect these lunar eclipses. So the scientists or astronomers, let's say astronomers, can predict eclipses years in advance. That's why in this I showed to you that it's from 2023 down to like 2026, 2029, 2020, 30. So, yes, they are also accurate because astronomers can predict this one in advance using first is the positions of Earth, Moon, and Sun. So every year they will study how is the sun revolve around, I mean, the Earth revolve around the sun and its rotation. So, yes, they can I predict because of the positions of these three. And next one is they use orbital mechanics. It's like they use mathematics to identify, like, for example, the position, and they have this certain, like, solution how to know that this eclipses will happen. And also the third one that they are using are satellite tracking and computer simulation. So we have satellites outside the Earth. So they use that one also in identifying the eclipses that will happen. So yes, this can be an exact date that these eclipses will happen. So for highlights in 2030, these are also the things that will happen. It's like annular solar eclipse and the total solar eclipse. So you can see this one, the annular solar eclipse in Algeria, Tunisia, Greece, Turkey, Russia, North China, and Japan. And also in November 25, 2030, the total solar eclipse visible. It's in Botswana, South Africa, and Australia. So that's why sometimes we cannot, like, for example, tomorrow they will just provide information that there will be eclipses that will occur. But have you heard it in the news, right? That there will be eclipses that will occur that day.
I don't really watch the news, so I'm not very sure.
Okay, so it's fine. So heck, how can you get involved in eclipse events? So basically, if you're interested to this kind of events, you will watch, like, news about it, ask your family members, or you can just search about this on internet, different eclipses. So these are our key takeaways from this session. First is observing the eclipse can help us learn more about our closest star. We have the sun and its interactions with Earth. Again, if we will witness eclipse, like for example the solar eclipse, so we will know how the heat and energy, what's the condition of the heat and energy of our sun. And remember that the sun is what, can you still remember what is the sun's, what kind of star is the sun right now?
Uh, Red Giant.
Mm-hmm. No, not yet. It's still
Oh,
on that.
sorry, not the Red Giant. It's like in
What
the
was it?
middle place. I don't know what the name is, but it's the middle place, right?
Yes, yes. So think about it first. We discussed that one last time, right?
Yeah, I forgot the name. I just know it's the middle place of the sun.
It starts with letter M.
Why did I think of supernova?
Supernova. That's the like all after the red giant and all.
Wait. Um,
It starts with letter M. It's only letter M in that types of star or stages of star.
is it the main place?
Okay, what is it? Main
Pace? Main sequence pace. Main sequence pace.
main sequence star.
Oh,
Yes. So the sun is still in the main sequence and still on that journey of becoming a red giant. I mean, a red giant star. And it will still take a long period of time that it will reach. So that's why if this eclipse, we need for us I mean not normal people, but for us, it's just we just watch or view these eclipses for such a like to witness this unexpected, I mean this event that people will just watch this for because this when you witness eclipses it's like a beautiful like view, but for its deeper reason why do we need to or why is it that we need to observe the eclipse is because of this. And sun is very important because it provides sunlight, and it without sun there will be no life on earth. So yeah, it's also important to have eclipse so that we will know the current status of the heat and energy coming from the sun. And the second one, we have eclipses reveal insights into Earth's ionosphere, which affects our technology and communication system. And remember that sometimes, like, there is a poor connection on every places because of this kind of events. So again, when we talk about the ionosphere, this is the layer of the Earth's upper atmosphere that plays a big role in our radio communication. So this one, ionization happens here, and this is mainly due to the solar radiation. And why is it important? This ionosphere that we are talking is very important because, again, it also provides, it's more on signals. So this one reflects our radio waves back to the Earth. That's why there is a long distance communication. We can talk to the people that is not near to us, like we can use our mobile phones for connection. So that's why it is important. And also this one can affect GPS signals and also satellite communication. And satellite communication is very important as well. And just in a short information about ionosphere, during daytime, there is a more ionization time. So this is better reflection of some radio waves. So that's why during daytime, people will experience a strong signal, and during a nighttime there is a less ionization. So that's why some part of it, like it weakens the communication.
Oh,
And the third one is eclipses are a natural wonder that have and will continue to occur in the coming years. Always be ready to safely view it from wherever you are in the world. So, you never tried to witness this kind of events, this kind of eclipses?
yeah, because it's either, I don't know, because we don't have the material or we just are not, we don't have time.
But right now in your country, oh, but
Mm-hmm.
you never tried it yet, right?
Um, Not yet. I'm usually too lazy to do it, but
Okay, so it's fine though, but it's interesting to witness this kind of. I mean, it will just only happen twice a year, once a year, though. So that's a wrap of what we discussed for today. Do you have anything that you wanted to share about what we learned today? Again, what did you learn? Like, what are those things that you remembered from this discussion and you think that it's very important to remember?
not really. That's not that much.
No more things to ask about
Yeah.
or what?
No.
Okay, so we have still 10 minutes.
Yay. Okay. Um, Hold on. Give me a second.
Okay, anything to share or what? Nothing?